Hello, my name is Jim Paradise, and I am a software engineer at Stratus Technologies. My position is on-site partner engineer at Red Hat. With me today are Bob Manchek and Lei Xiao. They are software engineers with the FT Linux Development Group, and we're here today to introduce a new open source technology by Stratus called lksm. That stands for Live Kernel Self Migration. The idea is to migrate a bare metal server from one physical server platform to another so that servers can be taken out of service for repair without interruption of applications. While there is a short pause in the application, there is no downtime. So here we are to show you how it works.
Here we have a server connected to fiber channel storage serving video up to a client. Suppose this server was showing intermittent soft errors. We would like to take it out of service, but we don't want to halt any services it's providing. With lksm, we can bring a backup server online with no downtime and minimal service interruption. Here we bring in our backup server and hook it up. This server has two network adapters, one for regular traffic and one for migration traffic. We could do this all on a single NIC, but we prefer not to saturate the server NIC with migration traffic. Next, we power on the backup server and let it bring up the migration environment. Upon receiving a migration request, the backup server reboots into a stub kernel running off of RAM disk in crash kernel space. It then launches the migration target software, which receives and processes commands and data from the running server. Now we've started the migration. The first thing that the running server does is send over the entire contents of physical memory. Once we're done sending this over, though, we have a problem. Since the system and applications have been running all this time, by the time we're done, many pages of memory could have changed in the meantime. This is where Stratus's memory tracking technology comes into play and enables us to perform this migration on a running system. Our memory tracker keeps track of which pages have changed state and which have been redirtied since we started the memory copy. We then perform a number of so-called brownout passes, where we send over only those pages that have changed. Since this pass should take much less time than the full copy, even fewer changes will have been changed by the time we're done. Thus, each brownout pass should be shorter than the previous one. When the number of changed or dirtied pages falls below a certain threshold, we then perform what's called a blackout pass. This is the final step in the migration. We halt all other processing on the system and remove all devices except for the migration NIC. We then copy over the last few modified pages and the CPU state. That's what's happening now. As you can see, the video is frozen during this time because we are copying over the final bits of state and reinitializing devices. Once all of this is done, the backup server will come to life and the original server will halt, and we will resume the application on the backup server. And there we go. Now at this point, the migration is complete. All that remains is to power down the original server and move the Penguin.